Welcome back, everyone, to the Before AGI podcast. We've been looking at a lot of pretty interesting developments in AI lately, but today we're going to be diving into something I think is truly transformative.
Oh, yeah.
AI agents. And I think forget about, just your basic chatbots. I think a lot of people have heard about those.
Right.
We're really talking about intelligent systems that can act independently, they can learn from their experiences, and they're really, I think, starting to shape the future of technology as we know it.
Yeah, and many people are calling 2024, the year of the AI agents. And that really just goes to show how fast things are moving.
Exactly.
And for you guys out there who are tech enthusiasts and professionals, this is something that you're no doubt seeing more and more of.
Yeah, absolutely. So today in this deep dive, we really want to understand, what are AI agents?
Yeah.
What are the different kinds that are out there? How are they actually built? What can they do? And also, what are some of the challenges and some of the exciting, future directions in this field?
Yeah, I think it's great to give everyone a really clear, insightful graph of this crucial area because AI is always expanding, and this is a big part of it.
Exactly. And to do that, we've taken a look at a bunch of different sources about AI agents,
Yeah.
kind of going back to those early AI systems that were designed for very specific tasks, all the way to what we're seeing today.
Right.
Which is much more autonomous, capable entities.
Exactly.
So let's get right to it. So what exactly is an AI agent?
So at its core, right, an AI agent is something that can perceive its environment. So it's got sensors. Think of it as like seeing or hearing or any way of taking information in, right?
Yeah.
And then it can act upon that environment using what we call actuators.
Okay.
So it can move, it can communicate, it can do things.
Yeah.
And the goal is to achieve objectives, right, to actually complete tasks.
Yeah.
But what really sets agents apart, I would say, is their autonomy.
Okay.
So you have an agent that can learn from what it experiences.
Yeah.
It can adapt. It becomes independent of the initial information that you give it.
Yeah.
It's not just doing exactly what you told it. Through interacting with its environment, it teaches itself and refines its abilities.
So it's really a shift, right, from that AI that we're used to be thinking of where it just follows a very specific set of instructions
Yeah,
to something that can almost think for itself and act on its own.
exactly. That's exactly it. We're going from those simpler models that were good at one thing, predefined task,
Yeah.
and now we're moving towards systems that can perform these self-determined actions and meet goals without someone, a human, constantly guiding them.
Right.
And this is a huge shift, especially for you guys out there in tech, because we're seeing growing interest in, all these industries of how AI agents can change enterprise workflows, tackling complex problems, assisting with coding, and even doing this intricate multi-step planning.
Right.
You can imagine it really streamlining operations
Yeah.
and really unlocking efficiency.
Yeah, I mean, and that's one of the big things I've heard about, this concept of agentic AI. Is
Yeah.
that just like a new buzzword, or is it really signifying something important?
It's more than just a buzzword. It really captures this momentum, right, behind these enhanced cognitive abilities. We're making machines that are more intelligent, that understand complex situations and can solve them.
Okay.
And it's less human oversight required.
Right.
So it's really a turning point, I would say, in AI.
Okay, so we have a pretty good idea now of what an AI agent is, but I know that there are different kinds.
Right.
So can you kind of break down that taxonomy? What are the different classifications and different typologies?
Yeah. So we can categorize them in a couple of ways, right? So we have their capabilities and intelligence, and then we have their internal structure and how they interact with either agents or systems.
Okay, let's start with capabilities and intelligence.
Okay, great.
What's like the most basic type of AI agent?
Okay, so that would be a simple reflex agent. That's the most basic form. It was decision solely on what it's sensing at that moment.
Got it.
So it has an immediate reaction. It's governed by a set of rules. So if-then rules, so condition action rules.
Okay.
So it doesn't store past experiences. It doesn't learn.
Okay.
It's really effective in environments where everything is visible and predictable.
So that's like if we think about like a thermostat.
Yeah, exactly.
So if the temperature drops too low, it turns on the heat.
Yeah.
It's just reacting to that current state.
Exactly. Or automatic doors that open when they sense motion, right?
Right.
Or a smoke detector that goes off when it senses smoke. Simple, efficient, but not very adaptable.
Got it. Okay, so what's the next level of intelligence then?
So the next level is a model-based reflex agent.
Okay.
So this is a step up because it maintains an internal model of the world.
Okay.
So think of it as a simplified mental representation
Right.
that allows it to keep track of how the environment is changing.
Okay.
And because of this, it can operate in environments where it can't directly observe everything.
Okay.
It makes inferences.
Right.
As it receives new sensory information, it updates its internal model.
So it's not just reacting to what's immediately in front of it. It sort of has this bigger picture awareness.
Exactly, exactly. So think about a robot vacuum cleaner that uses sensors to navigate your house.
Right.
It builds a map of the areas it's cleaned.
Right.
So that map is its internal model.
Okay.
Or a smart home security system that learns your routines, right?
Right.
And it models normal activity so that it can detect anything unusual.
Okay.
Network monitoring tools that track the data flow
Okay.
to spot anomalies. All of that is using an internal model.
Got it. Okay, what comes after the model-based agents?
So next we have goal-based agents.
Okay.
They have an internal model of the world, but they also have a goal,
Okay.
or a set of goals.
Okay.
So unlike reflex agents, which responds to the current situation, goal-based agents, they actually look for a sequence of actions
Right.
that will lead to the outcome that they desire.
Okay.
So they plan beforehand.
Right.
And that makes them much more capable.
So it's not just about reacting to the environment or understanding the current state.
Yeah.
It's about actively trying to get to a specific place.
Exactly.
Okay.
A perfect example is, like a navigation app.
Right.
You tell it where you want to go, that's the goal, and then it figures out the turns, the routes.
Yeah.
So that's the plan.
Okay, got it. And then we move on to utility-based agents.
Yes.
What is the utility part?
So utility-based agents, they go a step beyond.
Okay.
It's not just about reaching the goal.
Okay.
They want to maximize their utility,
Okay.
their reward, right,
Okay.
in the process.
Okay.
So think of utility as a measure of how desirable a particular state or outcome is
Right.
based on certain criteria.
Right.
So this is often defined by what we call a utility function.
Okay.
So when there are multiple ways to reach the goal, a utility-based agent is going to choose the path that gets it there in the most optimal way,
Okay.
considering things like time, cost, efficiency,
Okay.
even user preferences.
Right.
This is a big thing when we're talking about real-world applications because we want them to be optimal,
Right.
not just complete the goal.
Right.
Right? That's about efficiency. That's about cost effectiveness.
So it's not just about getting there. It's about getting there in the best way possible.
Exactly. So if we go back to that navigation app example, a goal-based agent might just find the fastest route.
Right.
But a utility-based agent is going to find a route that maybe balances speed with fuel efficiency
Right.
and avoids toll roads, if that's what the user prefers.
Right.
It's maximizing the utility based on what the user wants.
Right. So it's taking those things into account.
Exactly.
Okay, that's a really helpful distinction. And then the last category under capabilities is learning agents.
Yes.
This sounds like where things get really interesting.
This is where it gets really dynamic.
Yeah.
Right? Learning agents are the ones that can adapt and improve over time.
Okay.
They learn from experience. They get feedback.
Okay.
They don't just rely on pre-programmed knowledge.
Right.
They have mechanisms that allow them to refine their understanding
Okay.
of the environment and the consequences of their actions.
Okay.
This is really important, again, for real-world applications because things change.
Right.
So they have to be able to adapt.
Right.
And they have to get better over time.
So they're not fixed.
They're not fixed. They evolve. They get better.
They evolve.
Yeah, they get new information, and they change their behavior.
Right.
Think about personalized recommendation systems
Right.
that learn your tastes
Right.
over time, or spam softwares that learn to identify new kinds of spam.
Yeah.
Game-playing AI. The more it plays, the better it gets.
Right. That makes sense. Okay. So that covers how agents differ in their abilities.
Right.
Now, what about how they're categorized based on their structure and how they interact?
Okay, so now we're talking about how they're organized internally and how they communicate and work with other agents or systems.
Got it.
So the first type is hierarchical agents.
Okay.
So they organize their decision-making into a hierarchy
Okay.
where you have high-level agents
Right.
managing the overall goals,
Right.
and then you have lower-level agents that are handling specific, more detailed tasks.
Right.
So this is really good for complex operations because it breaks it down.
So that's almost like, a CEO who gives the strategic direction to the department heads who then manage their teams on specific tasks.
Exactly.
Okay.
Think about, a complex manufacturing process.
Yeah.
Right? You have a high-level agent that's in charge of overall production targets, but then you have lower-level agents that control the machines
Right.
or different stages
Right.
of the assembly line.
So it makes sense for tackling those kinds of really intricate tasks.
Exactly. Exactly.
Okay, what's next in terms of structure?
So next we have multi-agent systems,
Okay.
sometimes called MAS.
MAS, okay.
So this involves multiple AI agents
Okay.
that work together.
Okay.
They could be collaborating, they could be competing
Okay.
to achieve some common goal or individual goals.
Okay.
right?
Okay.
By leveraging the different skills and specializations of each agent,
Okay.
you can tackle really complex problems that a single agent couldn't handle.
So like a team of experts.
Exactly.
Exactly.
Each with their own expertise working on a big problem.
Right. And they can even have, as you were saying before, different foundation models.
Exactly. Exactly. So within the system, you can have different agents, and each agent could be powered by a different foundation model.
Right.
So that means they can have different brains for a specific job.
Right.
So you choose the best brain for the job.
Got it. Okay. And the last category in this kind of structural view is hybrid agents.
Yep.
What's the idea behind that?
So hybrid agents combine the strengths of both reactive and deliberative architectures,
Right.
which we'll talk about in a little bit.
Okay.
But essentially, they can react quickly
Okay.
to immediate situations.
Okay.
But they also have the ability to plan and think strategically.
Got it.
This allows them to be very adaptable and effective in complex, changing environments where you need both.
Right.
You need to be quick and you need to be smart.
So you want to have the best of both worlds.
Exactly.
The reflexes and the strategic thinking.
Exactly. So think about a self-driving car again.
Yeah.
Right. It needs to react instantly to avoid pedestrians.
Yeah.
But it also needs to plan the route to get you to your destination.
Right.
Or those warehouse robots we talked about. They have to avoid obstacles, but they also have to plan the most efficient path.
Right.
So they have both.
Right. Or even like a video game.
Exactly.
Right. So reacting to what the player does, but also having that long-term strategy.
Exactly. The game AI.
Got it. Okay. So this is giving us a really good kind of foundational understanding of the different types of AI agents that are out there.
Yeah.
You mentioned architectures.
Right.
So let's go into that. Let's go into the architectural blueprints.
Right.
How does that actually determine what these agents can do?
Yeah, so the architecture is fundamental. It really dictates the agent's core capabilities and how it interacts with the world.
Okay.
So we have these four main architectural patterns.
Okay.
We have reactive, deliberative, hybrid, and then the architecture for learning agents.
Okay.
They all kind of have their own way of doing things.
Okay. And we talked about reactive and deliberative a little bit
Yeah.
when we're talking about hybrid.
Right.
So let's go a little bit deeper into those first.
Yeah.
So what is a reactive architecture?
So a reactive architecture is all about a direct link between sensing the environment and taking action.
Okay.
So the agent looks at the current state and reacts immediately based on a set of rules.
Okay.
There's no internal model.
Okay.
There's no memory. There's no planning.
Got it.
It's a simple perception-action loop.
Right.
So think input-output. Very simple.
Okay.
The strength here is speed.
Okay.
They're not thinking, they're reacting.
Right.
And that's crucial for situations that are time-critical.
Right.
They also have this decoupling.
Okay.
So the comparents are operating independently, and that can actually enhance the stability of the system.
Okay, so speed and simplicity are the major advantages there.
Exactly.
But what are the limitations?
They don't learn,
Okay.
and they can't handle anything complex or new.
Right.
It's very inflexible.
Okay.
It can only work in stable, predictable environments.
Okay.
So that robot vacuum cleaner that we talked about, right, that changes direction when it bumps into a wall.
Yeah.
That's reactive.
Okay.
Or a traffic light that changes based on traffic flow.
Right.
Or even those non-player characters in a video game.
Yeah.
You know, the very basic ones.
Right. Okay.
Those are all reactive agents.
Got it. Okay. And then we move to the deliberative architecture.
Right.
So this sounds like a lot more thinking and planning is going on here.
Yeah, they're much more thoughtful.
Okay.
So they maintain a detailed internal model of the environment.
Okay.
Think of it as a symbolic representation
Right.
of the world as they see it.
Right.
And they make decisions based on logic and reasoning.
Okay.
So they reason about their goals,
Okay.
the current state of affairs,
Okay.
the possible actions. A common framework is something called belief, desire, intention,
Okay.
which is BDI
BDI.
architecture, and it tries to mirror human cognitive processes.
Okay.
So they're using logic.
Okay.
They're using planning algorithms
Right.
to figure out the best course of action.
Okay.
And they have this control loop,
Okay.
which is perceive.
Right.
Then you reason.
Right.
Then you plan.
And then you act.
And then you act.
So they're really thinking before they act.
They are.
Okay. What kind of applications are really suited to this kind of approach?
So think about self-driving cars.
Okay.
That high-level navigation,
Right.
figuring out the route, the best route to a faraway destination,
Right.
or intelligent personal assistance.
Right.
They need to understand a conversation,
Right.
So they have to think about the context,
Right.
or sophisticated healthcare systems.
Okay.
Analyzing patient data
Okay.
to develop those care plans.
Okay.
So the strength is making strategic decisions.
Okay.
The downside, as you can imagine, is it's computationally intensive.
Right.
It's slower,
Right.
right? Because they're thinking things through,
Yeah.
and they rely heavily on having a complete, accurate internal model,
Right.
which is not always easy.
And now hybrid architectures, and we talked about them a little bit before, so
Right.
that's really the idea of combining those two approaches, right?
Exactly. It's
Right.
the best of both worlds. So
Yeah.
you integrate the reactive and deliberative components.
Okay.
It's often in a layered design.
Right.
So reactive layer for quick things, deliberative layer for the high-level planning.
Right.
You're fast and you're strategic.
So the self-driving car is that perfect example where you have the braking is reactive,
Exactly.
but the route planning is deliberative.
Exactly.
Okay.
Warehouse robots, right? They need to avoid collisions, but they also need to plan their routes.
Right.
Or even those game AIs
Right.
that react to your moves, but also have a strategy.
Exactly.
Or smart home systems
Right.
that react to your voice commands.
Right.
But they optimize your energy usage.
Right. Over a longer period.
Exactly.
Got it. Okay.
So lots of different ways that this can be used.
And then the final one is the architecture for learning agents.
Right.
How is that structured so that they can actually learn?
So what's different here is you're integrating machine learning.
Right.
So machine learning components are part of the agent itself,
Okay.
and they have these specific elements that allow them to adapt and improve
Okay.
based on experience.
Okay.
So you have, typically a learning element that makes improvements.
Okay.
You have a performance element that selects actions.
Okay.
A critic that evaluates how well they're doing.
Right.
Gives feedback.
Right.
And a problem generator that suggests new actions
Okay.
for exploration.
Okay.
Right.
Right.
And the learning can happen through different ways.
Right.
Supervised learning, so learning from data that's labeled.
Right.
Unsupervised learning, finding patterns in data that isn't labeled.
Right.
Reinforcement learning, trial and error.
Right.
And they have this cycle.
Okay.
Perceive, learn, act.
Okay.
So they're constantly refining, improving based on what works and what doesn't.
So they're always getting better.
They're always getting better.
Okay.
They're looking at what works and what doesn't.
So those personalized recommendations we were talking about before.
Exactly.
That's streaming services, spam filters.
Game AI.
Game AI.
It's all about learning.
Right. Okay. This is a really good overview of the different ways that these AI agents are actually designed.
Yeah.
And kind of the blueprints. So let's shift our attention to how they actually operate in practice.
Okay.
What is this agentic workflow that I keep hearing about?
So the agentic workflow describes how AI agents tackle tasks,
Okay.
but with minimal human intervention.
Okay.
This is a step beyond that traditional rule-based automation, right?
Yeah.
So it's much more flexible. It can adapt.
So it's not just pre-programming a sequence of commands.
It's not.
Okay.
At its core, agents are not only executing tasks,
Okay.
they're figuring out how to approach them.
Okay.
They're designing their own workflow
Right.
dynamically, right?
Okay.
And they're using all these tools that are available to them
Right.
and capabilities.
Okay, so what are those components?
Okay.
What are the steps?
So first of all, we have AI agents.
Okay.
That's the foundation.
Right.
Then we have large language models.
LLMs.
LLMs, yeah.
Okay.
They provide reasoning, planning, natural language processing,
Mm-hmm.
so they can understand instructions,
Right.
formulate plans, communicate,
Right.
and then you have tools,
Okay.
external resources or internal capabilities.
Okay.
So web search, APIs,
Okay.
code interpreters, software.
So the LLM is almost like the brain,
Yeah, the brain.
thinking and planning.
Yeah,
And then the tools are how it iterates with the world.
exactly.
Okay.
The tools allow it to act.
Right.
So then we have these steps.
Okay.
So first, plan.
Okay.
You break down a task into subtasks.
Right.
And then you determine the sequence.
Okay.
Then, execution.
Okay.
You use the tools to carry out the plan.
Right.
Then you have reflection.
Right.
You assess the outcome.
Okay.
How are we doing?
Right.
Do we need to improve?
Okay.
Then iteration.
Right.
Adjust the plan.
Right.
Record steps.
Right.
Until you achieve the goal.
Right.
And then we have feedback mechanisms where
Right.
you can get input from humans or other agents
Right.
to guide decision making.
Right.
And for the multi-agent systems,
Yeah.
we have orchestration frameworks to manage the whole workflow.
Okay.
It's very dynamic, right? It's adaptive. It's like a human tackling a complex project.
Right. You plan, you act, you review, you adjust.
Exactly. Exactly. It's that ability to plan, act, evaluate, refine.
Right.
That makes it so powerful.
Okay. I mean, this is really interesting, but I'm sure there are limitations and challenges too, right?
Yeah, of course.
What are some of those?
Yeah, despite all this progress, there's still a lot we're figuring out.
Right.
One big one is reasoning and generalization.
Okay.
So those simple reactive agents, they don't have complex reasoning.
Right.
They can't apply their knowledge to new situations.
Okay.
Even deliberative agents, if they don't have all the information, they struggle.
Right.
And then we have this issue of hallucinations
Yeah.
in agents using large foundation models.
Right.
So they generate outputs that are incorrect
Right.
or nonsensical.
Right.
And then generalization,
Yeah.
applying knowledge across different contexts.
Right.
It's a hurdle.
It's a big hurdle. I mean, hallucinations, That's something that's getting a lot of attention right now.
Yeah, it's a big problem.
What are some of the other limitations?
So another big one is explainability
Okay.
and transparency.
Right.
So many of those AI models, especially deep learning models, they're like black boxes.
Right.
It's hard to know why an agent made a decision.
Right.
And this is a concern, right?
Right.
Especially in applications where we need to trust the reasoning.
Right. Like in healthcare or self-driving.
Exactly. And even in those reactive systems, that have all those agents interacting, sometimes the collective behavior is opaque.
Right.
You can't predict it.
Right.
You can't explain it.
Yeah, and it makes sense because if you don't understand how it's making decisions, you can't really trust it fully.
Exactly.
Okay. What about some of the limitations just from a practical standpoint?
Okay.
Like from actually deploying these things?
So computational complexity is a big one,
Okay.
especially for those deliberative agents that are doing all that reasoning and planning.
Right.
It takes a lot of processing power and time.
Right.
And if you need quick responses, that's a problem.
Right.
Right. And maintaining those internal models, that can be computationally expensive.
Right.
And then you have system integration challenges.
Okay.
So you're trying to get these AI agents to work with existing systems, databases, API,
Right. All the infrastructure we already have.
legacy systems.
Yeah.
And it's complex.
Right.
It can be time-consuming.
Right.
And coordinating those multi-agent systems, making sure they share information securely.
Right.
That adds another layer of complexity.
So it's not just about